So here we have CH3, CH2, CH2, another CH2, an alcohol, a primary alcohol. So, and you have, basically you have a tosylate group here, with the phenol group here. So SO2, of course, is a double bond O, is a double bond O, and with a chlorine attached to it. So the first thing here is the alcohol is acting as a nucleophile. It's a nucleophile, so you're giving the alcohol the chance to attack sulfur. Now remember, elements like phosphorus, sulfur can have more than 4 bonds. So don't be confused if you see sulfur with more than 4 or 5, more than 4 bonds. So this oxygen comes right down here, attacks sulfur. But now you have way more bonds than sulfur can hold. So what it does is it allows a chlorine to take these extra pair of electrons here. So when you take the extra pair of electrons from here, now you have, what do you have? A CH3, CH2, CH2, CH2. Now you have bonded these two, the alcohol and the tosylate group. So remember, our main agenda here is to make the alcohol to turn the hydroxide in the alcohol to a good leaving group, in this case a tosylate, so that we can form an alkyl halide after we move the leaving group out of the reaction. So now the second step would be so now we have bonded. So when we bond these, you have the O here, and you still have your hydrogen. Remember, the hydrogen not out of the equation yet. You still have your hydrogen, and so, but now you bonded these two. So sulfur come here, and then you have your phenol group, and then your CH3 group. Right. So still have your extra electron here. So now, as you can see, this is it's nearly a tosylate group, but there's one thing left. This hydrogen here. This hydrogen here should not be there. So pyridine comes along. Pyridine is like this. Comes along. You have a nitrogen with extra pair of electrons, and attacks this hydrogen here. Let me see. Attacks this hydrogen here. So when it attacks hydrogen, it takes it away, forms a bond with itself here. So now what do you have? You have CH3, CH2, CH2, CH2. Now you got oxygen with 2 pairs of electrons, sulfur, the whole tosylate group here, the phenol group, CH3. Now this is a very good leaving group. It's a tosylate group, and it's a really good leaving group. So what you can do now is this thing will just leave by itself as a very good leaving group. Now you can bring alkyl group, which could be chlorine or bromine. What you can do is you can be like CH3, CH2, CH2, CH2. Then this could react. Could react with the chlorine or bromine, whatever you want to react. And now, as you can see, the chlorine would attack this carbon here, and it would be CH3, CH2, CH2, CH3, CH2, 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 bond with Cl. Now you got your alkyl halide. So as you can see, we went all the way from alcohol with a bad leaving group to a tosylate, which is a very good leaving group. Then after we got our good leaving group, then we reacted it with an alkyl group. Then we have our alkyl halide.